So at the end of our last class, we talked a little bit about scientific notation, converting between standard notation and scientific notation. So let's take a peek at that. So if I have 32 million, what's that going to become in scientific notation?
32.
Careful.
3.2.
3.2. We can only have one digit in front of the decimal point.
Power of 6.
Careful. 1, 2, 3, 4, 5, 6,
Oh,
7.
yeah, you gotta put that.
So 10 to the 7. How about this one? 9.1. Yep, it's going to be negative because it's a small number. 1, 2, 3, 4. Negative 4. If I'm going the other way, what do I do with this?
Just add 5 decimal places.
Yeah, we move the decimal point over 5 spots. We have to add some zeros. 1, we don't have to add any zeros there, but 2, add a 0, 3, 4, and 5. Makes that 530,000. How about this one? To the left, because it's a negative, so that means it's a small number. So 1, 2, add a 0, 3, 4, 5, 6. So that is right there. Okay, well today what we want to do is we want to look at operations with numbers in scientific notations. We've talked about operations with numbers before, how when we're adding or subtracting, we must have the same name. 5 inches plus 3 inches is going to become 8 inches. When we add, not only do we need the same name, but when we add, we're going to combine the counts and then keep that same name. Same when we subtract. So with scientific notation, what part of the scientific notation signifies the name? Well, yeah, the 10 to the power of 6. When we talked about adding and subtracting whole numbers, we talked about the place value of the digits. That's really the name is their place value. You have to line up the place values to do the operations. Well, the power of 10 is the place value of scientific notation. That's the name. So when we add or subtract numbers in scientific notation, we must have the same power of 10. So we might have 4.8 times 10 to the 9th. I'm going to put that in parentheses just to separate it. That doesn't mean I have to do anything there. It's just separating the number. Plus 2.3 times 10 to the 9th. Well, now I have the same power of 10. I have the same name, which means my answer is going to be times 10 to the 9th. I keep the same name, and I combine the counts. 4.8 plus 2.3 is, well, 7.1 times 10 to the 9th. Or 7,100,000,000 if you did it all out. Yep. If you had that in cash right now, you could pass your math class. You wouldn't care about math class.
I'd be out in California right now. Soaking up the sun rays. It's probably waking up right.
Actually, in California, it'd still be 6:50 in the morning. You'd be nowhere near waking up.
What?
In California, it'd be 6:50 in the morning right now. You'd be nowhere near waking up yet.
Fuck yeah, I would be. I would be 6:51.
Yeah, but if you had that much money, you wouldn't care. Okay, so now we have the same power of 10. So we have the same name. So this is going to be 10 to the 4th. We're going to combine the count. 7.9 plus 4.8 is 12.7. Now I'm going to argue we're not done there. Can anybody tell me why? The decimal's in the wrong spot. We can only have one digit in front of the decimal point. We have to change this to 1.27.
You have to add 1.
So now we got to move the power of 10. Now this number got smaller, right? So the power of 10 has to get larger by 1. So 4 plus 1 is 5. So 10 to the 5th. So we might have 6.8 times 10 to the negative 6th plus 5.3 times 10 to the negative 6th. So we go to add these. Do we have the same name? Yes, we do. 10 to the negative 6th. Then what do we do? 6.8 plus 5.3 is 12.1. Then what? 1.21 times 10 to the... We add 1. This number got smaller, so this one gets bigger. Negative 6 plus 1 is a negative 5. You got to be careful with the negatives.
What are you doing?
Trying to confuse you. So what do I do to add these? First of all, what problem do you see? Different power of 10. 10 to the 5th and 10 to the 6th. Normally what I would do is I would change them to the higher power of 10. So the 6.97 times 10 to the 6th is going to stay the same. This one's going to be times 10 to the 6th. Now if the power of 10 gets larger, the number has to get smaller. So this is going to become 0.42. Now I have the same... A little confused, Brian. So now I have the 0.42 plus the 6.97 is 7.39. What's that, Brian? So where did 3.2 come from? Oh, you're reducing this by 1? Oh, no, you can only reduce this number by moving the decimal point. Behind the 2? Because that doesn't change the value at all. Subtraction is the same way. We have to have the same name. Here we do have the same name. So this is going to be times 10 to the 7th. 9.34 minus 8.61 is 0.73, right? 0.73, correct? Are we done? Say no. Why not? Why aren't we done? No. We don't have anything in front of the decimal point here, so we've got to move the decimal point over. Now this time we move the decimal point to make this number larger, so the power of 10 has to get smaller. 7 minus 1 is 6. Not so bad? It's stupid?
I was just talking about it.
So, talk me through this one. What did I do? Okay, 7.45 minus 6.98 is 0.47 times 10 to the negative 6. We keep the same name. Where'd the negative 7 come from? Negative 6 minus 1 is negative 7. Gotta be careful with the negatives. Those negatives are going to try to bite you. What's that? So anyway, when we multiply or divide, we do not need the same name. So the 3.2 times 10 to the 8th can be multiplied by 2.7 times 10 to the 3rd without any problems. Because when I multiply, I'm going to combine the counts. 3.2 times 2.7 is 8.64. But then I'm also going to combine the names. 10 to the 8th times 10 to the 3rd. What do we do with that? 10 to the 11th. We add the powers. 8 plus 3 is 11. When we're multiplying, we add powers.
Oh, that's nice. I like multiplying. What if you have 10 to the 6 and another 10 to the 6? Do you add them to 10 to the 12?
Yes, you would. When you're multiplying. So what do we do here? 4.5 times 2.2 is 9.9. Times 10 to the negative 3. Very good. 5 plus negative 8 is negative 3. .7 times 10 to the negative 4th times 6.2 times 10 to the 13th. What are we going to get? Well, 3.7 times 6.2 is 22.94. Times, negative 4 and 13 make 9. So are we done?
Yep.
Say no.
No.
No. What do we need to do yet? So this is 2.294. The power of 10 gets smaller or larger? This number got smaller, power of 10 gets larger. That's 10 to the 10th now. What's that?
Math is like Spanish, second language.
So let's start out with a division problem.
Oh, no.
What do we do? 2.294 divided by 3.7 is 0.62. Times, what do we do with the powers of 10 when we divide? We're going to also combine the names, but this time we're dividing. 10 to the 7th divided by 10 to the 4th will be 10 to the 3rd. We subtract the powers. Very good. So let's take 1.728 times 10 to the negative 5th divided by 1.2 times 10 to the negative 13th. Let's do the numbers first. 1.728 divided by 1.2 is 1.44 times 10 to the... What's negative? Careful. Negative 5 minus a negative 13 is negative 5 plus a positive 13, or 8. 10 to the 8th. You guys ready to practice some?
I thought we were practicing.
You guys want to see more examples? A few? No?
I'm good. I know what I'm doing.
Brandon, you need a couple
My
more?
calculator knows what it's doing.
You sure? You sure it's playing?
77 grams of sugar in this bottle.
That's like twice as many freaking...
On page 130, it's exercise 2.6, problems 59 through 81, the odds. On page 133, exercise 2.7, 1 through 23, the odds. It'll mention in there somewhere something about engineering notation. See if you can figure it out. If not, we'll talk about it next week. You okay over there, Huey?